Good morning, girls. Welcome back to the last week of your HBL before the May holiday starts. Okay, so this week we only be having lessons for Tuesday to Thursday because Friday is Labor Day. So I'll just run through what we are going to do for these 3 days. So for today's lesson, I'll be teaching on chapter 13, your electrical systems. Okay, and then Wednesday's lesson, you will spend that 1 hour offline time to do your tutorial 1 for electrical system. Then Thursday's lesson, we will use it to sum up all that we've covered in term 2. So I'll be putting up some of the videos for those questions that you were asking about in your tutorials for refraction and thin lenses. Okay, as well as summarize some of the key points for all the 4 chapters that we cover in term 2 together. Okay, so for those corrections or explanations, they'll be up on today. If you have the time, you can look at them first. Otherwise, Thursday, you can always come back and relook at them before we recap and do up the summary for this whole term. Okay, so I hope this will allay some of your fears and queries about the topics. But from what I see, most of you were actually able to do most of the questions. So don't worry too much. Don't give yourself too much pressure. If there's still any queries or questions, you can always just send them to me or get my number from your science reps and WhatsApp me directly if it's easier for you. Okay, and then when school reopens in June, we will continue to run through some of the things, because I think some things when it is done face to face, you may actually visualize it better or feel more secure that yes, I actually know them. Okay, so don't worry, and let's enjoy the last week of the HBL as well as your upcoming May holidays, not June anymore. Okay. Right, let's look at chapter 13, electrical systems. Okay, on this big chapter, we're going to look at what is the significance of electrical systems in daily life. How do the different parts of the electrical system work together to enable devices to work in our homes, as well as how can varying the components like the resistors and switch affect the output like the brightness of a bulb of the electrical system. Now this chapter comes in a big part. You have 3 parts to it: flow of electricity, effects of an electric current, and household electricity. But for this week's lesson, we'll only be touching on 13.1, the flow of electricity. So this picture here shows the earphones that you commonly use to listen to the audio from your HBL lessons, or to enjoy your favorite music, or to watch your movies. Now your earphones, they can only work when the earphone jack plug is properly connected to the player, so that it allows electricity to flow through the earphones. Similarly, for all electrical appliances to work, electricity must flow through the electrical appliance. So what actually is electricity? Okay, electricity is a form of energy. And from your primary school, you have learned that energy can be converted from one form to another. It cannot be created nor destroyed. So some of the ways that we can generate electrical energy are from your wind energy, like in the windmill, solar energy, or the tidal wave energy from the tides. Okay, all these can be used to generate electrical energy. And electrical energy can be converted to heat, light, sound, and kinetic energy in household appliances. For example, you have your cookers to produce heat to cook your food, your lamps or your light bulbs to give you light energy to brighten up the house, your radio or your MP3 players give you your sound energy, even your TV. And then your fans give you your kinetic energy, for examples. Right, let's look at what electric current is. Okay, electric current is actually the flow of electricity, and it is defined as the rate of flow of electric charge. So an electric current is measured by the amount of electric charge that is moving per unit time past any point in the circuit. So the SI unit for current is the ampere. We represent with the capital letter A. 1 ampere of current means that you have 1 unit charge that flows in 1 second, amount of electric charge. So 1 ampere means 1 unit charge per unit time, so in 1 second. We also use a smaller unit, the milliampere, which is represented by small letter m and capital letter A. And 1 ampere is actually equals to 1000 milliampere, just like you learned that 1 liters is equals to 1000 milliliters. Okay, so similarly, 1 milliampere is just 1 divided by 1000 amperes, or 0.001 amperes. Right? So electric current is measured by amount of electric charge moving per unit time. Okay? So hence, we have this formula here, I equals to Q over T, where I is the electric current that is measured in amperes, Q is the electric charge measured in the units called coulombs, capital letter C, and time is the time taken for the charge to pass through a point in the circuit, and it is measured in seconds. Okay, so we're going to use this formula, I equals to Q over T, to do a work example next. Okay, example, a current of 1.2 amperes flows through a lamp for 1 minute. Calculate the total charge passing through the lamp. So you have the formula, I equals to Q over T. I is your current, 1.2 amperes. Q is the charge that you want to calculate. T is the time, but it should be measured in seconds. So to calculate the total charge, Q, it will be Q equals to I times T. So your current, I is 1.2 amperes. The time is 1 minute. Convert it to 60 seconds. So our answer is 72 coulombs, capital C, for your charge.